Today we are going to see about the type of fin, that is long fin, short fin insulator and short fin non-insulator. Fin is the extended surface to dissipate the heat in the working medium. So to avoid the heat generation and the lagging inside the material, fin is used to give the better efficiency to prevent the material and the process. So in that we are going to see about the short fin end insulated problem, and the problem is the aluminum rod 2.5 cm in diameter and 16 cm long from the wall. It is maintained at 260 degrees Celsius. The rod is exposed to an environment at 16 degrees Celsius. The convective heat transfer coefficient is 15 watt per meter square Kelvin. Calculate the heat loss by the rod. Take thermal conductivity, that is K, 190 watt per meter Kelvin. So the question is in the top of the video. In the entire surface it will display in the top of the video. So the given data is D. Diameter is given 2.5 centimeter. We have to convert it into meter. That is 0.025. We have to divide by 100 and we will get it converted into meter. And L, that is 16 centimeter. We have to divide by 100. That is 0.16 meter. And TB, that is surface temperature. So this is the medium that is working. So the fin is called extended surface. This is the surface. So it will extend the fin. So on the surface or the temperature is 260 degrees Celsius. We have to convert it into Kelvin. That is 273 atmono. That is 533. So T infinity is 60 degree. T infinity is nothing but the surrounding or the surface or the environmental temperature. 16 degrees Celsius, that is 273 atmono, 289 Kelvin. So H is the overall heat conductive transfer coefficient, 15 watt per meter square Kelvin, and K is thermal conductivity, 190 watt per meter Kelvin. So in question, they asked you to find about the Q. Q is heat loss. So the Q, it is short fin, end insulated or long fin. So nothing is given in the question. So that is the one trick is there to find whether it is a long fin or a short fin. We have to find the L/D ratio. Whether the L/D ratio is less than 30 means it is considered a short fin end insulator. It is greater than 30 long fin. So L/D ratio, the L is 0.025 divided by 0.16, we will get 6.4. That is minimum of 30. So this is short fin end insulator. So we found out that is the short fin. In the HMT data book, 10th edition data book, that is 61 page number, for the short fin end insulator, Q formula is available. That is HPKA power 0.5 TB minus T infinity. Tan H, there is a whole single term, tan H MJ. So before going to find out, we have to know what is per meter, what is area and what is M. So M is mass, A is area and P is per meter. So with the constant values of D and diameter, we will find pi D, that is per meter's formula. Pi by 4 D square, that is area's formula. We will get some values like this. This is a step. It is a normal max. So it is easy to understand. So M, that is mass. That formula is root of HP divided by Ka. It is available in the page number 61. To find mass equal to root of HP divided by Ka. By substituting all these things in the formula, that is 15 into 0.0785 divided by 190 into 4.8 divided by minus 4, you will get mass as 3.5. That's unit is meter minus 1. Meter power minus 1. That is mass sort of formula. So it is available in the data book. It is in the last line of the page number 61. So we will find mass. So we have to substitute in this Q formula. In the previous step, we found out all the H, P, Ka and M. So by substituting in the Q's formula, it is available in the page number 61 in the 10th edition of the HMT, that is heat and mass transfer data book. So 15 into 0.0785 into 190 into 4.9 10 to the power minus 4. The whole term gets 0.5, and temperature difference, that is Tb minus T infinity, is 533 minus 289. So that is ML is the multiplication question for the whole term tan h. That is hypotenuse tan. It is available in the calculator. We have to press hypotenuse tan. We will get tan h. So for the same, we have to find the values. 3.5 into 0.16. Substitute all the things in the cube formula. We will get the answer as 41.03 watts. So for the surface temperature 533 Kelvin and the surrounding temperature 289 Kelvin, we will get the answer Q, that is heat loss by the fin. So surface வந்து fin வந்து heat loss பண்ணியிருக்கிறது வந்து 41.03 watts. It is an heat dissipated the extended surface to use the to maintain the temperature inside the material or the process. So it is a short fin insulated type problem. Thank you.